Hello. Hello guys. Hello Mr. and Mr. Ryan. Alright?
Yeah.
Okay, so we have a string of integers from 0 to 9. Yeah? So for example, the string of numbers 1, 1, 1, 2, 2, 2, 3, 4. And then our task is to find the largest substring of length 3.
2, 2,
Okay.
2.
And then, okay, you get it, yeah? So the substring contains only one unique digit. So it should be 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, etc. Okay? Yeah? So two requirements. Substring of 3. The second requirement is one unique digit. This means there are only 10 possibilities, right? There are only 10 possibilities. 0, 0, 0, 1, 1, 1, 2, 2, 2, etc. to 9, 9, 9. Okay? Simple. Okay? So what's your source? Come on. What's your source?
Brute forcing.
Brute forcing. How do we brute force? Yes,
Checking
obviously.
every possibility.
How? I mean, there are two ways of checking possibilities. How?
You check every number.
How do we check the possibility? We want to find out largest 3 digit in the string, in the numbers, right? This substring of 3 needs to contain only one unique digit. One way is that, look, because there are only 10 possibilities, yeah? And let's just check from 999 backwards. If it's 999 in the string, yes, we return it. If not, it's AAA in the string, yes, we return it. One case is that if we don't find such string, we return an empty, okay? For example, like 1, 2, 3. There's no such substring that contain only one unique digit, right? Then we return empty, okay? So that could be one way, yeah? 999 AAA. We check backwards. And as long as we find the substring in the original string, immediately we just return it because that's the largest one. That's one way. The other way is just continue to check this substring, right? This substring, is it satisfying this requirement? Basically this one, because we're checking the 3 digits at a time. Is it one unique digit? Yes, we remember it, right? Is this the same?
No.
No. And then we just keep moving, eh? That could be a way to do it, right? And then we remember the maximum. For example, like, if this is the same, yeah, then look, this is obviously not the same, right? Yeah, but for simplicity, we just keep moving. So these 3 digit, 3 digit, 3 digit, 3 digit, 3 digit, 3 digit. Okay. So which way you think is better?
Backwards.
Yeah, that would be better. Okay, so let's quickly write this. Okay, define just the largest 3. Okay, and we given this as. So we just do this. For I in range, we start from the 9, right? Because it could be start from 9 up to 0. Up to 0. So the end, not including, we should give it a -1, and then the step would be -1. This string would be A equal stri. First of all, we convert the integer into the string, yeah? And we times 3. Okay? 1 times multiple 3. What does it give us? 1 string multiple 3. What does it give us?
3 ones.
3 ones, exactly 1 on 1. How about this? 1 times 3. 1 times 3. Your turn.
3.
Exactly. Okay, so this is very basic. We're done both. Okay. So look at the multiple. Right? This is a string multiple. Okay. So we converted this the A will be 999 AAA, etc. Okay. Now we just say if A in S, right? If it's a substring of that, then we will just return A, right? And otherwise, if we can't find anything, we just return empty. Okay, what's the time complexity? If the way down. Look, if the number.
Yeah, easy.
Why is the n? Look, n is the number of character in a string. Okay, so why is it the n? Look, this one we iterate 10 times. So this is a constant loop. But here we check if a substring if it's in the original string, right? Then that's going to take n time, right? There's a famous KMP string pattern matching. So we don't want to go into more details here. But in general, this time complexity is n. Okay. Well, like you can think about it as n. Okay. That's one way. Okay. So the other way we're talking about, we can just do go through for I in range n if number of characters in the original string, so n minus 2. We're going to check until that every possible substring of 3 digits. How do we check if the substring contains only one unique number? One way would be d equals s I plus 3. Okay, so this is the substring of 3 characters. Then how do we check it? If the length of the set of d, right, we convert it to a set. If it only contains one unique number, then we just do this length of the set, convert it to the substring of 3, and then we remember, we need to remember this answer. Answer at the beginning is empty, and we need to do this answer equals the maximum of answer and then d, right? And then we finally return this answer. This is the first way of doing it, okay? Come on, what have you learned today? Last question. What have you learned today? What's the problem? Okay.
That is 3 same digits number in string.
Yeah, we want to find out. We are given a string of numbers. Okay, Eric. We are given a string of numbers. Yeah, positive numbers from 0 to 9. So there are 10 possible digits in a string only. Right? And we want to find out the largest substring of 3 that contains only one unique digit. So basically, there are only 10 possibilities. Yeah, from 999 AAA backwards to 000. How do we solve this problem? What have we learned today?
Going backwards.
So how do we backwards?
99887.
Yeah. We basically brute force. Yeah, we check the 999 AAA 77 if it's in the substring. Okay, if it's in the substring. We when we talk about time complexity, we ignore this constant time, right? Because of this outer loop iteration, we only iterate 10 times. Right, this is a constant. Okay. And the other way is we continuous checking every possible substring of 3, and then if it's only containing one unique digit, we remember the maximum value of it. Okay, that's it for today. Goodbye.
Goodbye.
Bye bye. Thank you. Bye bye.
Bye.